Hello there, and welcome to Sealed, where the strangest questions in all of science are turned over slowly, patiently, until the unknown stops feeling like a riddle and starts to feel like a place you could rest inside. Tonight, we are going somewhere you can never return from. Not a mountain, not an ocean, not a frozen pole at the edge of the map, but a door in the fabric of reality itself, a place where the rules you have trusted your whole life begin to soften, then bend, then quietly let go. We are going to fall. Not for a moment, not for an hour, but in a strange and beautiful sense, forever, because tonight we are asking what would happen if you fell into a black hole and never stopped falling at all. Before we begin, before we drift out past the last stars and into the dark, I would love to know where you are listening from tonight. Perhaps you are somewhere warm, wrapped in blankets with the lights already low. Perhaps it is raining softly against your window, or perhaps the world outside is completely still. Wherever you are, whatever the hour, you have found your way to a quiet corner of the universe, and I am glad you are here. If this kind of slow, wandering journey is the sort of thing that helps you settle, I would be deeply grateful if you would like this video or subscribe to Sealed. It helps this gentle little corner of the cosmos find other people who might need a peaceful moment too. Other minds drifting somewhere out there in the dark, looking for the same stillness you are. Now, make yourself comfortable. Let your shoulders soften. Let your breathing slow. And let me take you somewhere no light has ever escaped from. Somewhere sealed away so completely that even time forgets how to move. Because the story we are telling tonight is not about a place we cannot reach. It is about a place that once reached will never let you go. Let us begin at the edge, and then slowly let us fall. Imagine, for a moment, that you are floating in space, not in a suit, not in a ship, not bound by any of the fragile machinery that keeps human beings alive out here. Just you, drifting, weightless, in the enormous silence between the stars. There is no up and no down. There is no wind, no sound, no warmth on your skin, except the faint, distant glow of a billion suns scattered across the black. You are calm, you are still, and ahead of you, there is something you cannot quite see. You cannot see it, and yet you know it is there. You know because of the way the stars behind it seem to bend, as though the darkness itself were a lens made of nothing. You know because of the way the light curves around a central absence, a perfect circle of pure black rimmed with a thin, trembling halo of distorted starlight. It is not a hole cut into space. It is space, folded so steeply that everything falls toward its center, and nothing, not even light, can climb back out. This is a black hole, and tonight you are going to fall into it. Take a breath. You have all the time in the world, or at least it will feel that way soon. Because one of the strangest truths about this journey is that time itself will not behave the way you expect. But we will come to that. For now, simply hold the image in your mind. You, small and quiet, drifting toward the darkest object the universe has ever made. There is a question that has haunted physicists and dreamers alike for more than 100 years. What would actually happen to a person who fell into a black hole? Not a rock, not a star, not a beam of light, but a conscious, breathing, feeling human being. What would you see as you approached? What would you feel as you crossed the threshold? And what, if anything, would remain of you afterward? These are not simple questions. They sit at the very frontier of what we understand, in the place where our finest theories begin to disagree with one another, where certainty dissolves and wonder takes its place. And yet, even as they defy us, they call to us. Because a black hole is not just an object, it is a boundary. It is the edge of the knowable, the last shore before an ocean we cannot map. To fall into one is to leave behind not just the world, but the possibility of ever describing what comes next to anyone who stayed behind. It is the loneliest journey imaginable, and also, perhaps, the most profound. For in falling, you would encounter the raw machinery of reality, stripped of all its gentle disguises, working exactly as it always has, indifferent and immense. So let us not rush. Let us fall slowly, the way everything worth understanding must be approached, one layer at a time. Let us begin by understanding what it is you are falling toward, this thing that bends the stars and swallows light. Because before you can understand what it would do to you, you have to understand what it is. And what it is stranger and more beautiful than almost anything else in the universe. To understand a black hole, you have to understand gravity. And to understand gravity, you have to let go of the idea that it is a force reaching out to grab you. That was the old picture, the one we carried for centuries, the one that imagined invisible strings pulling apples toward the earth and moons toward their planets. It served us well enough. But it was not the whole truth. The deeper truth, the one that lets us understand black holes at all, is that gravity is not a force pulling through space. Gravity is the shape of space itself. Picture a great sheet stretched taut, smooth and flat in every direction. This is space, or at least a simple picture of it. Now imagine placing something heavy upon it. The sheet sags. It curves downward, forming a gentle valley around the weight. Anything rolling nearby will curve as it passes, drawn toward the dip, tracing a path bent by the shape of the surface. It is not being pulled by the heavy object directly. It is simply following the curve, moving as straight as it can across a landscape that is no longer flat. This is what mass does to the universe, the sun, the earth, your own body. Every scrap of matter presses into the fabric of space and time, curving it, shaping it, sculpting the paths that everything else must follow. The planets do not orbit the sun because a string connects them. They orbit because the sun has carved a valley in space-time, and the planets are forever rolling around its rim, falling endlessly without ever reaching the bottom. Now imagine making that valley deeper, take more mass, and press it into a smaller and smaller space. The valley steepens, its walls grow taller, the paths bending around it curve more sharply. Squeeze enough mass into a small enough volume, and something extraordinary happens. The valley becomes so steep, so deep, that its walls turn vertical, then curve inward, then close over the top entirely. The dip becomes a well. The well becomes a shaft plunging down into a depth from which nothing can climb out. And at a certain boundary, a certain critical distance from the center, the escape becomes impossible, not just for rockets or for runners, but for light itself, the fastest thing in all creation. That boundary is called the event horizon. It is the defining feature of a black hole, the line that separates the universe you know from the one you can never report back from. Cross it, and no signal you send, no light, no radio wave, no desperate cry will ever reach the outside again. Not because it is blocked, but because there is no longer any direction that leads out. Every path, every possible route now bends back toward the center. Out has ceased to exist. This is why we call it a black hole. It is black because no light escapes it, and it is a hole not in the sense of an empty pit, but in the sense of a place where the ordinary structure of the universe has, in some sense, come to an end. And it is not empty. Somewhere within it lies all the mass that made it, the crushed remnant of a dying star, or the accumulated weight of millions of stars, compressed beyond imagining. Black holes come in many sizes. The smallest we know of formed from single massive stars that at the end of their lives ran out of fuel and could no longer hold themselves up against their own weight. When such a star dies, its core collapses in an instant, falling inward faster than thought, until all of it, all that furious burning mass, is packed into a sphere just a few kilometers across, a star many times heavier than our sun, squeezed smaller than a city. These are the stellar black holes, and the galaxy is scattered with them, dark and silent, drifting between the stars. It is worth pausing to think about where such a thing comes from, because the birth of a black hole is one of the most violent and magnificent events the universe has to offer, and it began, always, with light. A star is a great and delicate balance, a lifelong struggle between two opposing forces. On one side, gravity, forever trying to crush the star inward, to pull all its enormous mass toward the center. On the other side, the fierce outward push of the nuclear fire burning in its core, where hydrogen fuses into helium, releasing the energy that makes stars shine and holding them up against their own weight. For millions or billions of years, these two forces hold each other in perfect tension, and the star burns steady and bright, a warm point of light in the dark. But no fire burns forever. Deep in the heart of a massive star, the fuel begins to run low. The fusion that held gravity at bay grows fitful, and the star, desperate, begins to burn heavier and heavier elements, fusing helium into carbon, carbon into oxygen, and onward, each stage briefer and more frantic than the last, the star building up a core of iron at its center. And iron is the ash of the stars, the element that cannot be burned for energy no matter how hard it is squeezed. When the core becomes iron, the fire has nowhere left to go. The outward push falters, and gravity, which has waited patiently for the whole life of the star, finally wins. What happens next takes less than a second. The core, no longer supported, collapses inward at a fantastic speed, falling in on itself, crushing together with such violence that the outer layers of the star, suddenly robbed of the ground beneath them, come crashing down after it and then rebound in a titanic explosion. This is a supernova, one of the brightest events in the cosmos, a single dying star blazing for a few weeks as brightly as an entire galaxy of 100 billion suns, scattering its outer layers across space in glowing clouds that will one day become new stars, new worlds, perhaps new life. Every heavy element in your body, the iron in your blood, the calcium in your bones, was forged in stars and flung out into space by explosions like these. You are, quite literally, made of the ash of dead stars. But at the very center, beneath the explosion, the core keeps collapsing. If the star was heavy enough, nothing can stop it. It falls past every barrier, crushing its matter smaller and denser than anything that has ever existed, until it disappears behind its own event horizon, sealing itself away, becoming a black hole. In the span of a heartbeat, a shining star has become a point of darkness so complete that not even light can leave it. The fire that burned for 1 billion years is extinguished, and in its place there is only the dark, and the deep bending of space, and the silent, patient pull of gravity, which has at last claimed everything. So the black hole you are falling toward tonight was once, perhaps, a star, a great and brilliant sun that lived and burned and died in fire, and left behind this quiet remnant, this sealed and secret thing. There is a strange poetry in it. The brightest objects become the darkest. The sources of all light become the places from which no light returns. And you, drifting toward it now, are drifting toward the grave of a star, toward the place where a sun folded itself away into the dark and never came back. But there are others, far larger, almost beyond comprehension. At the center of nearly every galaxy, including our own, there lurks a supermassive black hole, a monster containing the mass of millions or even billions of suns. Our galaxy's own center holds one about 4 million times the mass of the sun, a vast dark heart around which the entire spiral of stars slowly turns. And there are others, in distant galaxies, so enormous that they contain billions of solar masses, their event horizons larger than entire solar systems. The size of the black hole you fall into matters enormously, as we will see. It changes everything about your journey, everything about what you would feel, everything about how long you would last. A small black hole is a violent, tearing thing. A large one is, in a strange way, gentle, at least at first. But whichever you choose, whichever you drift toward in the quiet of this night, the ending is the same. Once you cross that boundary, once you pass the event horizon, there is no coming back. There is only forward, only inward, only down. Before we fall further, let us pause and marvel at a quieter miracle, one that has nothing to do with falling and everything to do with knowing. For it is worth remembering, here in the dark, that no one has ever seen the inside of a black hole, and yet we are so very sure that they exist. How can we be certain of a thing that gives off no light, that hides behind a horizon no signal can cross, that swallows every messenger we might send to it? The answer is a long and patient story, and it is one of the great quiet triumphs of the human mind. The idea came first, long before any evidence. More than 2 centuries ago, in an age of candlelight and horse-drawn carriages, a few careful thinkers wondered whether a star could be so heavy that not even light could escape its pull. They imagined dark stars, invisible suns, objects whose gravity was simply too great for their own light to leave. It was a curious thought, half forgotten, ahead of its time. And then, a little over a century ago, when Einstein reshaped our understanding of gravity into the bending of space and time, a soldier named Carl Schwarzschild, working out equations in the mud and cold of a wartime trench, found the first exact description of what such an object would truly be. He found the horizon. He found the radius of no return. He did not live to see where his mathematics would lead, but the seed was planted, and it grew. For decades, black holes remained little more than a strange possibility lurking in the equations, an oddity many great minds hoped was not real, a mathematical ghost they suspected nature would somehow forbid. But nature did not forbid it. Slowly, the evidence began to arrive. Astronomers found stars that seemed to be orbiting nothing at all, circling an invisible companion whose weight they could measure but whose light they could never see. They found places in the sky where matter, spiraling into some unseen center, blazed with X-rays as it was heated and torn, marking the presence of something dark and dense and impossibly heavy. One of the first, a source called Cygnus X1, became famous as the object that convinced even the doubters, a dark heart eating light in the constellation of the Swan. Then came the center of our own galaxy. Over many years, patient astronomers watched a cluster of stars near the heart of the Milky Way, tracing their motions night after night, year after year, decade after decade. And they found those stars whipping around an invisible point at tremendous speeds, orbiting something that had the mass of 4 million suns, yet gave off no light of its own, packed into a region no larger than our solar system. Nothing else could explain it. Nothing else could be that heavy and that dark and that small. It was a supermassive black hole, Sagittarius A star, the silent monster at the center of everything we call home, around which the sun and the earth and you yourself have been slowly turning your whole life without ever knowing it was there. And then, in our own time, in the span of just a few short years, two astonishing confirmations arrived, each one a kind of miracle. First, we learned to hear black holes. When two of them spiral together and collide, far across the universe, they send ripples through the fabric of space-time itself, waves that travel outward at the speed of light, stretching and squeezing everything they pass through by an amount smaller than the width of an atom. We built instruments so exquisitely sensitive that they could feel these ripples wash over the earth, and one day they did. A faint chirp rising from the collision of two black holes more than 1 billion years ago. The sound of space-time ringing like a bell. We had heard the universe's darkest objects announce themselves through the trembling of space. And then we saw one. By linking telescopes across the whole face of the Earth, turning our entire planet into a single vast eye, astronomers gathered enough light to capture an actual image of the shadow of a black hole, a dark circle ringed with the glow of superheated matter. Exactly as the theory had predicted, exactly as we had imagined it in the equations for 100 years. There it was, at last, not a calculation, not a dream, but a photograph. The silhouette of the unseeable, printed against the light it could not swallow. So when we say that black holes are real, we do not say it lightly, and we do not say it from having fallen in. We say it because we have watched stars dance around them, because we have felt space-time ring with their collisions, because we have seen their shadows drawn in fire against the dark. We have never touched one, and we never will. And yet we know them through patience, through mathematics, through the slow accumulation of evidence gathered by minds that refuse to stop wondering. There is something deeply comforting in that, I think, that the darkest, most hidden things in all creation can still be known, if only we are patient enough and curious enough to look. So hold that image again, you, drifting in the dark. Ahead of you, a circle of perfect black, ringed with bent and shimmering starlight. And now, gently, let yourself begin to fall toward it, because the fall has already begun. It began the moment you drifted close enough for its curved space to catch you. And from here on, whether you struggle or surrender, you are moving toward it. Let us see what you would see as you go. At first, the fall is almost imperceptible. You are still far away, and a black hole, for all its power, is not a vacuum cleaner sucking everything toward it. Gravity is gravity. If you were to replace our sun with a black hole of exactly the same mass, the Earth would not be pulled in. It would keep orbiting, calmly, exactly as it does now, in the cold dark, because the shape of space far from a black hole is no different from the shape of space around any other object of the same weight. The danger is not distance, the danger is closeness, and you, tonight, are drifting closer. As you approach, the first thing you notice is the light. The black hole itself gives off nothing, but the space around it is anything but empty. Falling toward many black holes is a great swirling disk of gas and dust, matter torn from nearby stars or drawn in from the surrounding void, spiraling inward in a flattened ring. This is the accretion disk, and it is one of the brightest things in the universe. As the matter spirals in, it is compressed and heated by friction and by the fierce tidal forces near the hole. Glowing white hot, then hotter still, blazing in colors the eye cannot even name. Some black holes are ringed by disks so luminous they outshine entire galaxies, beacons visible across billions of light years. But let us imagine, for the quiet of tonight, a black hole without such violence. A still one, a dark one that has finished its feeding and now waits, silent, at the center of an empty region of space. This way, we can fall in peace, without the searing radiation that would, in truth, cook you long before you ever reach the horizon. Let us grant ourselves this gentleness, this fiction of a calm approach, so that we can focus on the deeper strangeness of what falling truly means. So you fall, and the circle of black ahead of you grows, slowly at first, then faster. And around its edge, the starlight begins to do something impossible. The stars behind the black hole, the ones that should be hidden from view, blocked by the darkness in front of them, begin to appear anyway, smeared around the rim, curved into arcs, doubled and tripled and stretched into rings. This is gravitational lensing, the bending of light by curved space, and near a black hole it becomes extreme. The whole sky begins to warp. Stars that should be behind you appear ahead of you. The universe seems to wrap itself around the dark circle like a reflection in a curved mirror, and at the very edge of the horizon, in a thin, bright ring, you can see light that has orbited the black hole itself, circled it once or twice or many times before escaping back to your eyes. You are seeing around the hole. You are seeing the back of your own head, faintly, in a ring of ancient light. There is a special place along your fall, a boundary quieter than the horizon, but almost as strange, and it is worth lingering there for a breath. Physicists call it the photon sphere, and it is the distance at which gravity bends the path of light so severely that light itself is forced into orbit. Here, at this precise radius, a beam of light can circle the black hole in a perfect ring, going round and round, neither escaping nor falling in, trapped in an endless loop around the dark. Imagine that, a place where you could, in principle, look straight ahead and see the back of your own body, because the light leaving you would travel all the way around the black hole and return to your eyes. A place where the universe curls in upon itself, where sight lines become circles, where forward and around become the same direction. As you fall through this region, the sky does something no earthly sky has ever done. The bright ring around the darkness intensifies, sharpens, blazes. The stars of the entire universe, all of them, the ones ahead and the ones behind and the ones off to every side, are gathered and compressed into a shrinking, brightening circle above you, as though someone were slowly drawing the whole cosmos closed like the mouth of a bag. The darkness of the black hole swells beneath you until it fills nearly your entire field of view, and the light of all creation is squeezed into a thin, brilliant rim around its edge, growing smaller, growing fiercer, a single shining eye of everything that is, gazing down at you as you fall away from it forever. And here is a truth that catches in the throat, gentle as it is. Every image reaching you now is old. The light from the stars left them long ago, and it has climbed down into this well to find you. But as you fall faster and deeper, that light must work harder and harder to reach you, and less of it succeeds. The outside universe, seen from your falling eyes, begins to dim into blue, its colors shifting, its brightness concentrating into that shrinking circle overhead. You are watching the entire cosmos recede into a bright and distant point, the way a swimmer, sinking, might watch the surface of the sea pull away into a single trembling coin of light far above. This is the last you will see of the universe you came from. Not a wall, not a door slamming shut, only a slow and beautiful gathering of all the light there is into a single fading point, and then, as you cross the threshold, even that begins to change in ways that no theory can fully agree upon. The outside world does not vanish in an instant. It withdraws softly into a brilliance you are leaving behind, and you fall on into the region where the stars can no longer follow. It is beautiful, it is disorienting, and it is a warning, because the bending of that light is the visible sign of the bending of space, and the closer you fall, the steeper that bending becomes. The dark circle swells until it fills half your sky, then more. The ring of distorted starlight thins and brightens. And you begin to feel, for the first time, that you are no longer simply drifting. You are being drawn. Gently, inexorably, the fall is quickening. If the black hole is small, one of those stellar remnants only a few kilometers across, then even from a great distance you are already in trouble, though you may not yet know it. But if the black hole is enormous, a supermassive giant, then your fall remains smooth and calm even as you draw terribly close. You could plunge toward a supermassive black hole and feel almost nothing unusual in your body, no crushing, no stretching, nothing but the quiet acceleration and the swelling darkness ahead. This is the strange mercy of the largest black holes. Their horizons are so vast, their curvature so gradual across the scale of a human body, that you could cross the point of no return without any dramatic sensation at all. You might not even know the exact moment you passed it. And that is perhaps the eeriest thing of all. The event horizon is not a wall. It is not a membrane you would feel yourself puncture. There is no barrier there, no shimmering surface, no gate that clangs shut behind you. If you fell into a large enough black hole, you would sail across the most important boundary in the universe, the line beyond which return is forever impossible, and you would feel nothing. No jolt, no warning. The stars would still shine around you, distorted but present. Space would still look like space. You would drift on, thinking perhaps that you still had a choice, that you could still turn back if only you tried. But you could not. Somewhere behind you, in a place you could no longer point to, lies the boundary you have already crossed. And ahead of you, in every direction that now matters, lies only the center. Let us pause here, at this threshold, and understand what it truly means to have crossed it, because this is the heart of tonight's journey, the reason the word forever belongs in our question at all. The event horizon is often described as the point of no return, and that phrase, familiar as it is, hides something far stranger than it seems. We tend to imagine it like a current in a river, a place where the water flows too fast to swim against, where you are swept along whether you like it or not. And that picture is not wholly wrong. But the truth is deeper and more disquieting. Inside the event horizon, it is not merely that escape is difficult, or that the pull is too strong to resist. It is that the direction called out no longer exists. To understand this, you have to understand that space and time are not the separate things we imagine them to be. They are woven together into a single fabric, space-time, and near a black hole, that fabric is twisted so severely that the two begin to trade places. Outside a black hole, you can move freely through space. You can go left or right, up or down, forward or back. But you cannot move freely through time. Time carries you forward, always, at 1 second per second, whether you wish it or not. You cannot stop it. You cannot reverse it. The future is not a place you can decline to visit. It comes for you, inevitably, no matter what you do. Now here is the strange and terrible beauty of the black hole. Once you cross the event horizon, the direction pointing toward the center, toward the singularity at the heart of the whole, becomes like the direction of the future. It is no longer a place in space that you could choose to avoid. It becomes a moment in time that you cannot escape. Reaching the center becomes as unavoidable as reaching tomorrow. You could fire the most powerful rockets ever built, point them outward, burn every drop of fuel in a desperate bid to escape, and it would make no difference at all. You would simply be choosing which path through time you took to arrive at the center. You could not avoid arriving, any more than you could avoid growing older by running fast enough. This is what it truly means to fall into a black hole forever, From the outside, the falling seems endless, as we will see. But from the inside, the fall becomes something even stranger. Your future itself is redefined. The center of the black hole is no longer a location. It is your destiny, written into the shape of time, as certain and as unavoidable as death itself. Every road leads there. Every choice arrives there. The singularity is not somewhere you might go. It is when you are going. Sit with that for a moment, here in the quiet. The universe you came from still exists, somewhere behind you, in a direction you can no longer name. And ahead of you, in the only direction that time now allows, lies the center. You are falling toward your own future, and your future is the heart of the darkest thing that exists. And yet, remarkably, in the moments after crossing, you might still feel calm. If the black hole is large enough, the tidal forces, the difference in gravity between your head and your feet, remain gentle. You are simply falling, in free fall, weightless, as peaceful as an astronaut drifting in orbit. The horizon is behind you now, though you cannot see it. The center awaits, though you cannot yet feel it. And you have, perhaps, some precious time remaining before the end. For a supermassive black hole, that time might be measured in seconds, or even minutes, a strange final grace granted by sheer enormity. Let us spend those moments wisely. Let us understand what is coming, and why, no matter how gently the fall began, it cannot end gently. The force that will eventually undo you has a curious and almost gentle name. It is called the tidal force, and it is the same force that raises the tides in the oceans of the earth, the same force by which the moon tugs the seas into their slow daily rhythm. It arises not from gravity itself, but from the difference in gravity from one place to another. And near the center of a black hole, that difference becomes greater than anything else in the universe. Consider your own body, falling feet first toward the black hole. Your feet are closer to the center than your head. And because gravity grows stronger the closer you get, your feet are pulled more strongly than your head. Out in ordinary space, near the earth or the sun, this difference is so tiny you never notice it. The pull on your feet and the pull on your head are almost exactly the same. But as you fall deeper toward the center of a black hole, the difference grows and grows. Your feet begin to fall faster than your head, and so you begin, ever so slightly at first, to stretch. Physicists have a word for what happens next, and it is a word so vivid and so strangely tender that it has escaped the laboratories and entered common speech. They call it spaghettification. As you fall deeper, the stretching increases. Your body is drawn out, longer and thinner, feet racing ahead, head trailing behind, until you are pulled into a long, thin strand, like a single strand of pasta stretched between two hands. At the same time, you are squeezed from the sides, because all the different parts of your body are trying to fall toward the same central point, and so they are pressed together as the space around you narrows toward the center. Stretched lengthwise, crushed sideways, you become a thread, then a filament, then a stream of atoms drawn out along the final plunge. For a small black hole, this happens early and violently. The tidal forces near a stellar black hole are so extreme that you would be spaghettified while still outside the event horizon, torn apart before you ever crossed the threshold, unmade by the sheer steepness of the curvature. For such a black hole, there would be no calm crossing, no peaceful drifting past the horizon. You would meet your end in the approach, stretched into oblivion before the darkness had even swallowed you. But for a supermassive black hole, the story is different, and this is the strange gift of the giants. Because their horizons are so vast, the curvature of space across the width of your body remains gentle even as you cross the boundary. You could pass the horizon whole and unharmed, drifting peacefully, feeling nothing. The spaghettification would come only later, deep inside, as you fell toward the center and the tidal forces at last grew fierce. And so, the largest black holes offer you the longest journey, the deepest passage into the unknown, the most time to witness the strangeness before the end. How long? For the supermassive black hole at the center of our galaxy, 4 million times the mass of the Sun, you would have perhaps a handful of seconds after crossing the horizon before you reached the center and were torn apart. A few seconds, but seconds in which you would fall through a region of the universe that no information can ever leave, seeing sights no one on the outside could ever be shown. For the very largest black holes known, billions of times the mass of the Sun, you might have far longer. Minutes, perhaps. Minutes of falling through the dark interior of the strangest object in existence, before the tidal forces finally found you. It is worth dwelling, here in the quiet, on how utterly different these two fates are, the fall into the small black hole and the fall into the giant, because they reveal something deeply counterintuitive about the nature of these objects. We tend to imagine that a bigger, heavier, more monstrous black hole would be the more dangerous one, the more violent, the more sudden in its destruction. But the opposite is true, and the reason is subtle and beautiful. The danger, the thing that tears you apart, is not gravity itself, but the difference in gravity across your body, the steepness of the change from your feet to your head. And around a small black hole, that change is savage. A stellar black hole only a few kilometers across concentrates all its terrible mass into so tiny a region that the curvature of space near it is extraordinarily sharp. Fall toward one, and the pull on your feet would exceed the pull on your head so enormously, so quickly, that you would be stretched and torn apart, while still far outside the horizon, unraveled thousands of kilometers before you ever reached the point of no return. For such a black hole, the crossing is irrelevant. You would never live to see it. The tearing would come first, in the approach, brutal and total. But the giant is gentle, and this is its strange mercy. A supermassive black hole spreads its horizon across a distance larger than our entire solar system. And because the horizon is so vast, the curvature of space near it, across the mere span of a human body, is almost imperceptibly gentle. Fall toward such a black hole, and the difference between the pull on your feet and the pull on your head would be tiny, no more than you might feel standing on the earth. You could cross the horizon whole and unharmed and entirely unaware, drifting in perfect peace across the most significant boundary in all of physics, feeling nothing but the calm of freefall. The violence would come only much later, deep inside, in the final approach to the center, when the curvature at last grew fierce. So the largest and most monstrous black holes offer the gentlest and longest journeys, while the smallest offer only a swift and distant death. The bigger the darkness, the softer the crossing, the more time you are given inside. It is as though the universe, in its strange arithmetic, rewards you for choosing the more terrifying door. And it means that if you must fall, if you had any say in it at all, you would choose the giant, the supermassive heart of a galaxy, precisely because it is so vast. You would trade a quick death outside a small dark star for a longer, stranger, more wondrous passage into the sealed heart of a great one, a passage of seconds or even minutes spent falling through a region no eye has ever witnessed and returned from. A longer fall, a deeper dark, and more time, in the end, to wonder. And here we arrive at the deepest mystery of all, the one that no telescope can pierce and no equation can fully resolve. What is at the center? What is the thing you are falling toward? The destiny written into the shape of time? Our finest theory of gravity, Einstein's general relativity, gives an answer, and it is an answer so extreme that most physicists believe it must be wrong, or at least incomplete. It says that at the center of a black hole lies a singularity, a point of zero size and infinite density, where all the mass is crushed into a place smaller than an atom, smaller than anything, a point where the curvature of space becomes infinite, and the equations that have guided us this far simply break down, dividing by zero, returning nonsense, falling silent. A singularity is not a thing so much as a place where our understanding ends. It is the edge of physics, the frontier beyond which our theories cannot follow. And it is toward this that you are falling, this unimaginable point where everything we know ceases to apply. But before we reach it, before we try to peer into that final darkness, we must go back to the surface, back to the outside world, and consider something we have not yet faced. Because while you have been falling, feeling calm, crossing the horizon, drifting toward the center, something has been happening to time, and it is one of the strangest and most beautiful things in all of physics. For while your fall, from your own point of view, is swift and final, from the point of view of anyone watching, you never fall in at all. Let us leave your falling self for a moment, drifting toward the center, and let us imagine instead a friend, a companion who chose not to fall, who stayed behind in a ship at a safe distance, watching you go. What would they see? What would your fall look like from the outside, from the safety of the ordinary universe? The answer is one of the most haunting predictions in all of science, and it is the true reason the word forever belongs in our question tonight. To understand it, we must return to the idea that time itself is not fixed. We tend to think of time as a river flowing at the same rate everywhere, a universal clock ticking in unison across all of creation. But it is not so. Time flows differently depending on where you are and how you are moving. And in particular, time flows more slowly the deeper you are in a gravitational well, the closer you are to a massive object. This is not an illusion, not a trick of perception. It is real. Clocks tick more slowly near the surface of the Earth than they do high above it, so slightly that we need atomic clocks to measure the difference, but measurably, undeniably slowly. Near a black hole, this effect becomes overwhelming. This is not a fantasy dreamed up for the sake of black holes. It is happening around you, right now, tonight, in the room where you are resting. Time is passing very slightly more slowly at your feet than at your head, because your feet are a little deeper in the Earth's gravity than your head is. The difference is fantastically small, far too small to feel, amounting over an entire human lifetime to less than the blink of an eye. But it is real, and it has been measured, with clocks so precise that they can detect the difference in the flow of time between two shelves of the same bookcase, one raised a little higher than the other. Even here, even now, time is not quite the same in every corner of your quiet room. We rely on this strange truth every single day, though almost no one thinks about it. The satellites that guide us, that whisper directions to travelers and mark our positions on glowing maps, orbit high above the Earth, far from its gravity, where time runs measurably faster than it does on the ground. If we did not correct for this difference, if we did not account for the fact that time itself flows at a different rate up there than down here, the whole system would drift into error within hours, and our maps would lead us astray. Every time you have found your way by such a map, you have quietly trusted a truth that Einstein first glimpsed a century ago, that time bends, that it flows faster on a mountaintop than in a valley, faster in orbit than on the ground, faster far from a mass than near it. And so when we say that time slows to a standstill at the edge of a black hole, we are not inventing something exotic and impossible. We are simply following this same familiar effect, the one already woven into your satellites and your bookshelves and your very body, and pushing it to its ultimate extreme. A black hole is only a place where the gentle everyday truth becomes absolute, where the small slowing of time near any heavy thing grows so profound that, at the horizon, time as seen from outside stops altogether. The seed of the black hole's strangeness is already here, in the ordinary world, in the quiet difference between your head and your feet. The black hole simply takes that whisper and makes it a roar. As you fall toward the event horizon, time for you begins to slow relative to the outside universe, not from your own perspective. From your own perspective, your watch ticks normally, your heart beats normally, your thoughts flow at their usual pace. You feel nothing unusual about the passage of time. But to your friend watching from afar, something extraordinary is happening. They see your fall begin to slow. As you approach the horizon, you seem to move more and more sluggishly, as though the space around you were thickening into honey. Your movements stretch out, your gestures slow, and the light coming from you begins to change. Light is a wave, and as it climbs out of the deepening gravitational well to reach your friend's eyes, it is stretched, its waves drawn longer, its color shifted toward the red, then toward the deep red, then toward the infrared and beyond, into wavelengths the eye cannot see at all. This is gravitational redshift, and as you approach the horizon, it grows without limit. Your image dims, it reddens, it fades, and crucially, from your friend's perspective, you never quite reach the horizon at all. You seem to slow, and slow, and slow, approaching the boundary but never crossing it, frozen in an endless approach, your final image growing dimmer and redder and more stretched with every passing moment, until at last it fades entirely from view, not because you have crossed, but because the light has been stretched beyond all. You do not fall into the black hole. You fall toward it, forever. You hang at the edge, a fading ghost, an image red-shifting into darkness, your final moment stretched across the entire future of the outside universe. If your friend waited 1,000 years, 1,000,000 years, 1,000,000,000 years, and could somehow still detect the last faint whisper of light from your fall, they would find you still there, still frozen at the threshold, still not quite arrived. From the outside, your crossing takes an eternity. From the outside, you fall in forever and never land. This is the first meaning of falling forever, and it is a strange and lonely kind of immortality. In some sense, to everyone who stays behind, you never truly die. You simply fade, slower and slower, dimmer and dimmer, an eternal frozen image pressed against the surface of the dark. You become part of the black hole's surface. In a way, your information smeared across its horizon, your final instant preserved for as long as the black hole itself endures. And yet, from your own perspective, none of this is true. You do not freeze. You do not hang at the edge. You do not fall forever in any way that you can feel. You cross the horizon in an instant, smoothly, calmly, without even noticing the crossing, and you continue inward toward the center, toward the singularity, toward the end. Your own experience of time carries you swiftly onward, while the outside universe recedes behind you, and the last light of your friend, of the stars, of everything you left behind, chases you inward but can never quite catch up. Two truths then, both real, both correct, and utterly irreconcilable in their feeling. To the outside, you fall forever and never arrive. To yourself, you arrive swiftly and are gone. There is no contradiction here, though it feels like one. It is simply what happens when time itself bends, when the single river we imagined splits into countless streams flowing at countless different rates. You and your friend do not disagree about the facts. You simply live in different times now, and there is no longer any clock that can be shared between you. Let us make this stranger still, gently, the way you might turn a curious stone over in your palm. Imagine that as you fall, you agree to send your friend a signal once every second, a small pulse of light, a heartbeat of communication, so that they might know you are still there. Tick, you send one. Tick, another. From your side, nothing unusual happens. Your seconds pass as they always have, steady and even, and you send your little pulses out into the dark at their regular pace, expecting them to arrive at the other end just as steadily. But that is not what your friend receives. To them, your pulses arrive slower and slower. The first few come at something like the expected rhythm, but as you fall deeper, the gap between them stretches. A signal you send 1 second after another might arrive 2 seconds later, then 5, then 20, then hours apart, then years, then centuries. Each pulse must climb out of a deeper part of the well than the last, and so each takes longer to escape, and each is stretched and reddened more than the one before. Your steady heartbeat of light, even and calm from your side, arrives at your friend's window as an ever-slowing drip, the pulses spreading further and further apart, dimmer and dimmer, until the interval between them stretches toward infinity, and the last one never seems to arrive at all. And the final pulse you send just before crossing the horizon, that one your friend will wait for the longest of all. It will still be climbing toward them long after you yourself have reached the center and are gone. It will still be on its way when your friend has grown old. It will still be arriving, redshifted almost to nothing, when the stars themselves have begun to die. That last signal, sent in an ordinary moment of your fall, becomes a message with no end to its journey, a goodbye stretched across the whole future of the universe, forever approaching, never quite delivered. There is a loneliness in this so vast it is almost peaceful. You cannot reach back. Your friend cannot reach in. The bridge of light between you has not been cut so much as stretched beyond all use, drawn out into a thread so long that no message can ever cross it in any time that means anything. You are, from the moment you cross, more alone than any human being has ever been or could ever be. Sealed away not by distance, which love can span, nor by silence, which patience can outlast, but by the very structure of time, which nothing can undo. And yet your friend never sees you leave. To them, you are always just about to go, forever poised at the edge, forever fading, never fallen. In the cruel arithmetic of the black hole, this is as close as the universe comes to letting someone stay. Consider what this means, here in the stillness of the night. If you fell into a black hole and someone you loved watched from a safe distance, they would never see you go. They would see you slow and redden and fade, hovering at the edge of the dark, and they would carry that final frozen image with them for the rest of their lives and beyond, because in a sense that image would outlast them, outlast their world, outlast the stars. You would be, to them, forever falling and never fallen, forever leaving and never gone, and you, meanwhile, would already be somewhere they could never follow, somewhere no image, no signal, no memory could ever return from. You would be beyond the horizon, in the sealed interior of the dark, falling through your own swift and silent seconds toward the center of everything. There is a loneliness in this that is almost too large to hold. But there is also, if you look at it gently, a kind of tenderness, because in the strange arithmetic of space-time, the last light you sent out, the last image of you, is never fully erased. It lingers. It clings to the edge of the dark. And in that lingering, there is something that refuses, however faintly, to disappear. You fall forever from the outside, and forever, in this one strange sense, is not an ending, but a kind of staying. But let us return now to your own experience, to the swift inward fall, and let us ask what it would truly be like inside the horizon. For we have said that space and time trade places, that the center becomes your future, that escape becomes as impossible as avoiding tomorrow. But what would it look like? What would it feel like to fall through the interior of a black hole in those final seconds before the end? The honest answer is that we do not fully know, and this is part of what makes the question so endlessly fascinating. No one has fallen in and returned to tell us. No signal has ever emerged from beyond a horizon to report on conditions within. Everything we say about the interior of a black hole is the product of theory, of mathematics pushed to its limits, of equations followed into territory where they begin to tremble and strain. And yet, those equations have been so extraordinarily successful everywhere else, predicting the bending of starlight and the ripples of gravitational waves and the very existence of black holes themselves, that we cannot help but take their word for it, at least until they finally break down entirely. So let us follow them inward, cautiously, holding their hand as far as they will lead us. Inside the horizon, you continue to fall. The universe you left behind is now, in a strange sense, in your past, receding not into distance, but into a direction you can no longer reach, a time you can no longer return to. Ahead of you lies the center, and the closer you fall, the more the tidal forces grow. If your black hole is enormous, these forces remain gentle for now, and you fall in something like peace, weightless and calm. The strangeness of your situation hidden behind the ordinary sensation of freefall. What would you see? This is where it becomes truly mysterious. Light still exists inside the horizon. It still travels, still carries images. But all of it, like you, is falling inward. And so the light from behind you, from the outside universe, would still reach you, catching up from behind, showing you a distorted, compressed image of the cosmos you left, squeezed into a shrinking window overhead. Some analyses suggest that as you fall, the entire history of the outside universe might appear to play out above you, sped up, compressed, the future of everything you left behind racing past in your final moments. Others suggest more subtle and stranger visions. The truth depends on details we cannot yet fully calculate, on the precise nature of the black hole and the light around it. Let us try, gently, to feel what it would mean to be in a place where space and time have traded roles. Because it is perhaps the strangest idea we will touch tonight, and it deserves to be turned over slowly. Out here, in the ordinary world, you can hold still in space. You can plant your feet and refuse to move, staying in one place while time carries you forward. You cannot hold still in time, but you can hold still in space. This freedom feels so natural that you have never once questioned it. Inside the horizon, that freedom is gone, and a new and terrible one takes its place. There, the direction toward the center has become like the flow of time. And just as out here, you cannot plant your feet and refuse to move into the future, so in there you cannot plant your feet and refuse to move toward the center. The singularity is no longer a place ahead of you in space, a destination you might steer away from. It has become a moment ahead of you in time, a future as certain as tomorrow. To try to avoid the center of a black hole would be like trying to avoid next Tuesday by walking very quickly in some clever direction. There is no direction that leads away from it, because it is not a where, it is a when. This is why nothing can escape, and it is a far deeper reason than mere strength of pull. It is not that the gravity is too strong to fight. It is that escaping would require traveling backward in time, and that no one can do. Your rockets, your struggles, your desperate desire to turn back, all of these are simply different ways of moving through the time you have left, and all of that time flows in one direction only, toward the center, toward the end. In the strangest sense, the black hole does not trap you in space at all. It traps you in time. It makes your destruction not a possibility to be avoided, but a future to be met, as calmly and inevitably as you meet each passing second of this quiet night. And yet, remember, you might feel none of this as horror. In those final seconds of falling, weightless and calm, you would simply be moving, as you have always moved, into your own future. The only difference is where that future leads. There is a curious peace available in that thought, if you can hold it gently. To fall into a black hole is, in the end, only to keep doing what you have done every moment of your life. To move forward in time. To meet what comes. The center is only your next moment, and then your last, and you would arrive there the way you arrive everywhere, one instant after another, carried by the same quiet current that carries all of us, always, toward whatever waits ahead. But whatever you saw, you would keep falling, and the tidal forces would keep growing. And eventually, no matter how large the black hole, no matter how gentle the beginning, the stretching would find you. Your feet would begin to fall faster than your head. The difference would grow, second by second, then faster, then unbearably. You would feel yourself begin to lengthen, then to strain, then to tear. The spaghettification would arrive, gently at first, then with overwhelming and final force. And in those last instants, drawn out into a thread of atoms falling toward a point of infinite density, you would meet the singularity, the place where physics ends, the destiny written into the shape of time. And there we must stop. Not because the story ends, but because our knowledge does. What happens at the singularity itself, what becomes of the atoms that were once you, what the infinite curvature truly means, all of this lies beyond the reach of any theory we currently possess. General relativity says infinite density, but infinity is not an answer. It is a sign that the theory has been pushed past its breaking point, that something new must take over, something we have not yet discovered. To know what truly happens at the center of a black hole, we would need a theory that unites gravity with the quantum world, a theory of quantum gravity, and despite a century of effort, we do not yet have one that we fully trust. So the center remains sealed, not just physically, hidden behind a horizon no light can cross, but conceptually, hidden behind the limits of our own understanding. It is the deepest mystery in the cosmos, a place we can point to, calculate toward, fall into, and yet never truly comprehend. And perhaps that is fitting. Perhaps the darkest object in the universe should also hold its darkest secret, guarded not only by gravity, but by the boundaries of thought itself. It is worth understanding, softly, why our theories fail us here, because the failure is not a sign of carelessness, but a sign that we have reached a true edge. We have two great theories of the physical world, and each is magnificent, and each has been tested and confirmed to breathtaking precision, and yet they do not fit together. The first is general relativity, Einstein's theory of gravity, of curved space and bending time, and it rules the world of the enormous, the world of stars and galaxies and black holes. The second is quantum mechanics, the theory of the very small, of atoms and particles, and the strange fuzzy uncertainty that governs the tiniest scales of reality. Almost everywhere in the universe, these two theories mind their own domains and never quarrel. The very large and the very small keep to themselves. But at the center of a black hole, the very large and the very small are forced together. All the mass of a star, an object of cosmic scale, is crushed down into a point smaller than an atom, a realm where quantum uncertainty reigns. Here, and perhaps only here, and in the first instant of the universe itself, both theories must speak at once, and when they do, they contradict one another and dissolve into nonsense, into infinities, into equations that no longer mean anything. To describe the center of a black hole truly, we would need a single deeper theory that contains them both, a theory of quantum gravity, the great unfinished dream of modern physics. Brilliant minds have chased it for generations. They have built beautiful and intricate candidate theories with names like string theory and loop quantum gravity. But we do not yet know which, if any, is correct, because the one place we could test them, the heart of a black hole, is the one place we can never reach. And so the singularity remains not just unseen, but unknown, a genuine gap in human understanding, a place where the map simply runs out and the words end. It may be that when we finally understand quantum gravity, the singularity will dissolve into something less absurd, that the infinities will smooth away, that the point of infinite density will turn out to be some strange but finite thing, a knot of quantum spacetime, a bounce, a doorway. We do not know. What we do know is that the center of the black hole marks the current edge of the knowable, the frontier where our finest thoughts fall silent. And there is something almost sacred in that. To fall into a black hole would be to fall, in your final seconds, straight into the deepest unanswered question in all of science, to become part of the very mystery you spent your life wondering about. But we are not quite finished, because even though we cannot see the center, even though the singularity hides beyond our theories, there are other questions we can ask. Questions about what a black hole does to information, to matter, to the very idea of what survives. And these questions have led some of the greatest minds of our age into one of the most profound debates in the history of physics. Let us drift a little longer, here at the edge of understanding, and consider what might remain of you, of anything, after the black hole has done its work. For a long time, black holes were thought to be truly eternal. Once formed, they would simply sit there forever, unchanging, growing only when they swallowed more matter, never shrinking, never fading, patient and immortal at the centers of galaxies and the graveyards of stars. Anything that fell in was gone for good, erased from the universe, its information sealed away behind the horizon for all of time. This seemed strange, but not impossible. A black hole was a perfect trap, a one-way door, and whatever passed through it was simply lost. But in the 1970s, a young physicist named Stephen Hawking made a discovery that changed everything. By combining the physics of black holes with the physics of the quantum world, the strange rules that govern the smallest scales of reality, he found that black holes are not truly black after all. They glow, ever so faintly, with a whisper of radiation seeping out from the very edge of the horizon. This radiation, now called Hawking radiation, is unimaginably feeble for a large black hole, far too faint to detect with any instrument we possess. But it is real, and its implications are staggering. Because if a black hole radiates, then it loses energy. And if it loses energy, then it loses mass. And if it loses mass, then, over vast and unimaginable stretches of time, it must eventually shrink, and fade, and disappear. Black holes, it turns out, are not eternal. They evaporate. The process is fantastically slow. So slow that a black hole the mass of the sun would take vastly longer than the current age of the universe to evaporate. and a supermassive black hole would take longer still. A length of time so immense that our ordinary words for large numbers become useless. But eventually, in the far distant future, long after the last stars have burned out and the universe has faded into cold and darkness, even the black holes will go. One by one, they will radiate away their mass, growing smaller and hotter as they shrink, until in a final flash they vanish entirely, leaving nothing behind but a faint glow spreading into the empty dark. And here is where the deepest trouble begins. Here is where one of the greatest puzzles in all of physics is born. Because if a black hole evaporates completely, if it radiates itself away and disappears, then what happened to everything that fell into it? What happened to the star that collapsed to form it? To the matter it swallowed over the aeons? To you, drifting in through the horizon on this quiet night? If the black hole is gone and only faint featureless radiation remains, then it would seem that all the information about everything that fell in has been erased from the universe forever. This may not sound troubling at first. Things fall in, the black hole evaporates, everything is gone. Where is the problem? The problem is that the laws of physics, the deep laws that govern the quantum world, do not permit information to be truly destroyed. In principle, according to those laws, the present always contains the seeds of the past. If you knew the exact state of the universe now, in perfect detail, you could, in principle, run the equations backward and reconstruct exactly what it was before. Information is never lost, only scrambled, rearranged, hidden. Burn a book, and the information in its pages seems lost, but in principle it is still there, encoded in the light and smoke and ash, recoverable by a sufficiently godlike calculation. The laws of physics guarantee it. But a black hole seems to violate this guarantee. It seems to take information in, and then, through evaporation, destroy it utterly, leaving behind only featureless radiation from which nothing could ever be reconstructed. This is the black hole information paradox, and it is not a minor technicality. It is a direct conflict between two of our most cherished and successful theories, general relativity and quantum mechanics, a place where they contradict each other outright. And for decades, some of the finest minds in physics have struggled to resolve it. The debate has been long and fierce, and it is not yet fully settled, but the emerging consensus is remarkable. Most physicists now believe that information is not destroyed after all, that it somehow escapes the black hole, subtly encoded in the Hawking radiation, scrambled almost beyond recognition, but not truly lost. How exactly this happens remains deeply mysterious, and the attempts to explain it have led to some of the strangest and most beautiful ideas in modern science. One of these ideas is the holographic principle. It suggests, astonishingly, that all the information about everything inside a black hole might be encoded on its two-dimensional surface, its horizon, rather than in its three-dimensional interior, as though the inside of the black hole were a kind of projection, a hologram, cast from information written on its boundary. And some physicists have taken this further still, suggesting that our entire universe might work this way, that the three-dimensional world we experience might be a projection of information encoded on some distant two-dimensional surface, a cosmic hologram in which depth itself is a kind of beautiful illusion. These ideas remain speculative, but they have proven extraordinarily fruitful, and they emerged, in large part, from the simple and profound question of what happens to the things that fall into black holes. But the puzzle runs deeper still, and it leads to one of the most unsettling debates in all of modern physics, a debate that bears directly on your own quiet fall tonight. For if the information about you must escape in the Hawking radiation, and yet you also fall smoothly through the horizon feeling nothing, then something does not add up. Both cannot easily be true at once. And when physicists followed the logic carefully, some of them arrived at a startling and disturbing conclusion. Perhaps, they suggested, the horizon is not a gentle and unremarkable boundary after all. Perhaps, in order for the information to escape, the horizon must be a wall of blazing energy, a firewall, that would incinerate you the instant you touched it. This idea, when it appeared, threw the physics community into turmoil, because it seemed to force an impossible choice between principles that each seemed unbreakable. Either you fall smoothly across the horizon, as Einstein's beautiful theory of curved space insists you must, feeling nothing, drifting on into the dark, or you strike a firewall and are destroyed at the threshold, as the demands of quantum information seem to require. Both could not be true, and yet each rested on foundations we thought were solid. It was as though the universe were being asked to keep two promises that contradicted one another, and no one could see how it might keep them both. There is another idea, subtler and stranger, that tries to hold both truths at once, and it is called complementarity. It suggests something almost mystical, though it is rooted in careful physics. It suggests that there may be no single answer to what happens to you at the horizon, that the truth depends on who is asking. To your friend, watching from outside, you never cross at all. Your information is smeared across the horizon, thermalized, scrambled, and eventually radiated back out. And from their vantage point, that account is complete and consistent and whole. To you, falling, you cross smoothly and continue inward. And from your vantage point, that account is also complete and consistent and whole. And the reason there is no contradiction, the reason the universe does not break, is that no single observer can ever compare the two stories. Your friend can never follow you in to check. You can never send word back out. The two versions of events can never be laid side by side, and so they are permitted, by the deep logic of the cosmos, to both be true. It is a dizzying thought that reality itself might refuse to commit to a single story, might allow two irreconcilable truths to stand simply because no one can ever hold them both at once. And yet it may be closer to the heart of things than any simpler answer. These questions are not yet settled. The firewall, the smooth horizon, the scrambled radiation, the holographic surface, all of these remain live and argued and unresolved, the subject of papers and conferences and long passionate arguments among some of the cleverest people alive. We are, in truth, still falling toward the answer, still descending toward an understanding we have not yet reached. And the black hole keeps its secret, patient as always, while we circle it with our equations, drawing closer. Never quite arriving. So what would remain of you, after all? In this picture, you would not be truly, finally, absolutely erased. The information that made you, the precise arrangement of your atoms, the pattern that was your body and perhaps in some sense your mind, might be preserved, scrambled beyond all recovery, smeared across the horizon, and slowly leaking back out over unimaginable ages in the faint glow of Hawking radiation. You would be gone, utterly and irretrievably gone in any way that matters. And yet, in the deepest accounting of the universe, in the ledger of information that the laws of physics insist must balance, some trace of you might endure, not as a self, not as a soul, but as information, indestructible, scattered into the dark, part of the slow radiance of the dying black hole, part of the universe's refusal to ever quite forget. There is something in this that touches the same tender place as the frozen image at the horizon. Both are ways in which the universe, for all its indifference, does not entirely let go. The outside sees you frozen forever at the edge, fading but never gone. The deep laws insist your information is never truly destroyed, scrambled, but never erased. From every angle we approach it, the black hole seems to take everything, and yet leave behind the faintest, strangest echo. A shadow at the threshold. A whisper in the radiation. A refusal written into the fabric of reality to ever fully complete the disappearance. But we must be careful here and honest. These are the frontiers of physics, the places where the ground is soft and the maps are incomplete. The information paradox is not fully resolved. The nature of the singularity is not understood. What actually happens to a conscious being falling through a horizon? Whether experience itself could persist even for an instant beyond the point of no return. These are questions that lie at the very edge of what we can even meaningfully ask. And so as we drift here, at the boundary of knowledge, let us allow ourselves to wonder, gently, about the other possibilities. The stranger doors that some physicists have imagined might lie hidden within the dark. For the story we have told tonight, the story of stretching and singularity and slow evaporation, is the mainstream story, the one our best theories tell most confidently. But black holes are strange enough, and our knowledge incomplete enough, that other, wilder possibilities have been imagined, and they are worth visiting here in the safety of a thought, before we return at last to the world of the waking. Consider the wormhole. When physicists first solved the equations of general relativity for a black hole, they found something curious lurking within the mathematics. The solution seemed to describe not just a hole, but a tunnel, a bridge connecting one region of space to another, perhaps a vast distance away, perhaps in another universe entirely. This is the Einstein-Rosen bridge, the mathematical seed of every wormhole ever dreamed of in science and story. In principle, in the pure mathematics, it hinted that a black hole might be not just an ending, but a passage, a doorway leading somewhere else. The reality, sadly, is far less inviting. The simple wormholes that appear in the equations are not the tunnels of the imagination. They are unstable, collapsing faster than anything could ever pass through them, sealing themselves shut before any traveler could cross. And they connect not to convenient destinations but to strange mirror regions that may not exist in our universe at all. To make a wormhole you could actually travel through, a stable one, a traversable one, you would need forms of matter with properties we have never observed. Exotic matter with negative energy, holding the tunnel open against its own desperate urge to collapse. Whether such matter can exist in the quantities required, no one knows, and so the wormhole remains, for now, a beautiful possibility glimpsed in the mathematics, but almost certainly not what awaits you at the bottom of a real black hole. Consider, too, the white hole. If a black hole is a region that nothing can escape, only enter, then the equations also permit its opposite, a region that nothing can enter, only leave, a place from which matter and light pour outward, but into which nothing can ever fall. This is a white hole, the time-reversed twin of a black hole, and it appears in the same solutions, the same mathematics. Some have wondered whether the matter that falls into a black hole might somehow emerge from a white hole elsewhere, whether the singularity might not be an ending, but a transition, a bounce, a passage from one state to another. Perhaps, some have speculated, the interior of a black hole might give birth to an entirely new universe, expanding on the other side of the singularity, a cosmos budding from the heart of the dark, forever hidden from the parent universe that spawned it. These ideas are speculative in the extreme. There is no evidence that white holes exist, no sign of new universes budding from black hole cores, no observation to support the wilder dreams. They live in the realm of possibility not fact, and a careful mind holds them lightly, as wonders to be entertained rather than truths to be believed. But they remind us of something important. They remind us that the black hole is not merely a destroyer, not merely a trap, but a genuine frontier, a place where the deepest questions in physics come together, where the nature of space and time and information and existence itself are all pushed to their absolute limits. Whatever truly lies within, whatever the singularity truly is, it is a place where the universe keeps its most closely guarded secrets, and where our imagination, unable to see, is free to dream. And perhaps that is the truest answer to our question tonight. What would happen if you fell into a black hole forever? From the outside, you would fall forever and never land, frozen at the edge, fading into red and then into silence, a ghost at the threshold for as long as the black hole endures. From your own side, you would fall swiftly, crossing the horizon without a sound, drifting through the sealed interior for a handful of precious seconds, seeing sights no one on the outside could ever be shown, before the tidal forces found you and drew you at last into the singularity, that point where our knowledge, like everything else, comes to an end. And in the deepest accounting of the cosmos, some trace of you would linger, scrambled beyond all recovery, smeared across the horizon, leaking back out over unimaginable ages in the faint glow of the dying hole, until at last, in the far distant future, the black hole itself would fade, and even that final echo would join the slow cold radiance spreading into the endless dark. It is a strange fate. It is a lonely one. And yet, held gently, it is also strangely beautiful. For in falling into a black hole, you would touch the raw edges of reality, the places where space and time bend and trade and break, the frontier beyond which even our finest theories fall silent. You would go where light cannot return, where the future rewrites itself, where the universe keeps its deepest secret sealed away. Few journeys in all of existence are so profound. Few endings are so wrapped in mystery. And no traveler, in all the history of the cosmos, has ever come back to describe it. Before we turn back toward the waking world, let us drift once more into the far future, into the deep and distant time when even the black hole that swallowed you will meet its own quiet end. For we said earlier that black holes are not eternal, that they radiate, that they slowly fade. And the story of that fading is one of the strangest and most beautiful in all of science. A lullaby written in the language of almost unimaginable time. Picture the universe growing old, not in centuries, not in millions of years, but in stretches of time so vast that the numbers lose all meaning. First, over trillions of years, the stars burn out, one by one, the bright ones quickly, and the dim red ones with agonizing slowness, until at last the final star flickers and dies, and the galaxies go dark. The universe becomes a cold and quiet place, scattered with the cinders of dead suns, drifting in an ever-expanding blackness. And in that darkness, the black holes remain, the last great structures standing, patient monuments at the centers of dead galaxies, feeding now on almost nothing, waiting, and still time flows. The dead stars decay. Matter itself, over spans of time beyond all comprehension, may slowly come apart. And the black holes, at long last, begin in earnest to evaporate, radiating their mass away into the cold, growing smaller across aeons so immense that the entire history of the universe until now would be less than the blink of an eye by comparison. The supermassive black hole that took you in, the one at the heart of some galaxy, would be among the very last things in all of creation to go. It would outlast the stars. It would outlast the galaxies. It would outlast matter itself. It would hang there in the final darkness, radiating with excruciating slowness, the last warm thing in a cold and empty cosmos, shrinking by the faintest whisper across ages upon ages. And then, at the very end, something almost tender happens. As a black hole shrinks, it grows hotter, and as it grows hotter, it radiates faster, and so its final moments accelerate. After an eternity of patient fading, the last of it goes quickly, flaring brighter and hotter as it dwindles, until in a final soft burst of radiation, it is gone, the horizon vanishes, the center unravels, and whatever was sealed inside, all the information, all the scrambled traces of everything that ever fell in, including, in the deepest accounting, the faint indelible pattern that was once you, is released at last into the empty dark, spreading outward, cooling, dispersing, joining the endless quiet. There is no violence in this ending, no drama, only a slow and gentle completion, the softest possible full stop at the end of the longest possible sentence. The black hole, which took everything and gave nothing back for an eternity, finally opens its hand and lets go. And what it releases is not you, not any self that could know itself, but something more abstract and more enduring. The mere fact of your having been, encoded in radiation, indestructible, scattered into a universe grown old and cold and infinitely patient. In the end, the darkest object in all creation becomes, of all things, a source of light, faint and final, giving back to the emptiness the last echo of everything it ever swallowed. It is strange to find comfort in an ending so unimaginably distant, so far beyond any concern of ours. And yet there is comfort in it, a quiet one. It tells us that nothing is held forever, not even by a black hole, that every seal, however perfect, eventually loosens, that the universe, given enough time, gives everything back. You would fall in and be gone, and yet in a span of time too long to fear, even that swallowing would be undone, even that darkness would fade, even that most absolute of endings would, at the last, gently release its hold. Let us rest here now, in the quiet, as the darkness ahead grows soft and the last strangeness settles into stillness. Let us think, one final time, about what all of this means, not for atoms and equations, but for us, small and awake, gazing out at a universe so vast and so strange that it holds objects like these at its heart. There is a temptation, when confronting something as overwhelming as a black hole, to feel small and frightened and lost. And there is truth in that feeling. We are small. We are fragile. We are creatures of warmth and breath and light, utterly unsuited to the crushing dark at the center of a collapsed star. If you truly fell toward a black hole, without the gentle fictions we have granted ourselves tonight, you would be killed long before the interesting physics ever began, cooked by radiation, torn by tides, unmade in ways both ordinary and strange. The black hole does not care for you. It does not know you exist. It is indifferent, ancient, and immense beyond all human scale. And yet, consider this, that same small, fragile, warm creature, you, sitting here in the quiet, has managed to understand all of this, not by falling in, not by risking anything, but by thought alone, by curiosity, by the patient work of minds across generations, piecing together the shape of space, the bending of light, the flow of time, the whisper of radiation from the edge of the dark. We have never touched a black hole. We have never sent a probe inside one, never received a signal from beyond a horizon, never held a piece of a singularity in our hands. And still, we know all this. We have imagined the fall, calculated the stretching, traced the freezing of time, argued over the fate of information, dreamed of the doors that might lie within. From a small blue world, orbiting an ordinary star, in an unremarkable corner of one galaxy among billions, we have looked out into the darkest objects the universe has ever made, and we have begun, slowly, patiently, to understand them. Think of the long chain of quiet effort that had to happen for you to know any of this. Someone, long ago, had to wonder whether a star could be too heavy to shine. Someone had to work out equations in a freezing trench and glimpse the horizon in the mathematics. Someone had to watch the same patch of sky for decades, tracing the paths of stars around an invisible weight. Someone had to build an instrument delicate enough to feel space-time tremble, and someone had to link telescopes across the whole Earth to photograph a shadow. None of them ever saw the inside of a black hole. None of them ever fell. And yet, patiently, generation after generation, they assembled this understanding out of nothing but curiosity and care, and handed it down until it reached you here, tonight, resting in the dark, able to imagine the fall in vivid detail without ever leaving the safety of your bed. That is a kind of magic more real than any spell. That is what minds can do, and there is a comfort hidden in the very fear these objects inspire. For a black hole is in the end a reminder of limits, of the places we cannot go and the things we cannot know, and there is a strange relief in limits. We do not have to understand everything. We do not have to reach every center, solve every mystery, conquer every dark. It is enough to wonder. It is enough to have looked and imagined and marveled, and then to let the mystery remain, intact and beautiful, keeping it secret at the heart of the dark. The black hole does not ask to be solved. It only asks to be wondered at. And that, unlike falling in, is something you can do gently, safely, from exactly where you are, before drifting off to sleep. There is a kind of quiet triumph in that, and a kind of grace. It does not make us large. The universe is still vast, and we are still small. But it means that smallness is not the whole of the story, for we are the part of the universe that has learned to wonder about itself, the part that looks up at the frozen ghosts on the horizons of distant black holes and asks what it would be like to fall. And in asking, in wondering, in daring to imagine the journey into the dark, we touch something that no black hole can ever swallow. Not our bodies, which are frail, not our atoms, which would be scattered, but our curiosity, which reaches even into the places our bodies can never go. So perhaps that is the gift of the black hole, in the end. Not the fear it inspires, but the wonder. Not the sense of our smallness, but the astonishing fact that such small creatures can hold such vast ideas in their minds, and rest easy under them, even drift toward sleep beneath them. The black hole seals everything away, light and matter and time itself. But it cannot seal away the question. It cannot seal away the dream of the fall. And somewhere out there, right now, in the silent centers of 100 billion galaxies, these dark hearts turn slowly in the void, keeping their secrets, waiting, patient and eternal, while on one small world, minds like yours look outward into the dark and are not afraid, only curious, only full of quiet wonder at how strange and beautiful it all is. And as you rest now, as your thoughts grow slow and soft, and the day releases its hold, let that wonder settle over you like a blanket. You do not have to solve the mystery. You do not have to reach the center. You are allowed to simply drift at the edge of it, here in the warm dark of your own quiet room, letting the strangeness carry you gently toward sleep. The black hole will keep its secrets. The frozen ghosts will keep their long, slow vigil at the horizons of the stars. And you, safe and small and awake, are permitted only to wonder and then to rest. Somewhere, unimaginably far away, light is still climbing out of a gravitational well, stretched and reddened and slow, carrying the last image of something that fell in long ago and will go on falling from the outside forever. It is not lost. It is not gone. It is simply somewhere the rest of us can never follow, held at the threshold, fading but never quite fading away. And that, perhaps, is the most comforting thought of all, that even in a universe with objects as merciless as these, nothing is ever truly, completely, finally erased. There is always a trace, always an echo, always the faintest whisper of what was, lingering at the edge of the dark. Rest now. Let your breathing slow. Let the stars blur and the darkness soften. You have fallen a long way tonight, through curved space and slowing time, past the point of no return and into the sealed heart of the strangest thing that exists. And now you may simply drift, weightless and calm, no longer falling toward anything at all, only sinking, gently, into sleep. Thank you for spending this quiet time with me, out here at the edge of everything. If you drifted off before the end, that is perfectly all right. The dark will hold the story for you, patient and unhurried, ready whenever you return. And if you are still here, still listening, still wondering, then let this be the last thought you carry down into sleep, that the universe is vast and strange and full of sealed and secret places, and that you, small and awake and curious, are one of the few things in all of it that has ever paused to wonder why. Sleep well. The stars will keep turning. The dark will keep its secrets. And everything sealed, in the end, has a reason. Good night.